morning, afternoon, I don't know. Depends on when you're watching. Could be good midnight. Don't care. As long as you're enjoying your wonderful pre-calculus through digital means excitement. All right, so today we are, hold on. That's right. My border was underneath and I didn't like it. Okay, so today we are talking about hyperbolas, which is the last of the four conic sections, and I did say four. I did say four because there is also circles, which we didn't do because you technically cover that in geometry, so we're not doing it. But we are going to talk a little bit about it at the end of this video. That way you can identify when it's a circle versus when it's a hyperbola, a parabola, or an ellipse. So hyperbolas. Hyperbolas kind of function similar to the other ones, right? In the parabolas, all the points on the parabola was equidistant from the focus and the directrix. In an ellipse, all the points were equidistant from the sum of the distance to the two foci, the two focus points. In a hyperbola, bloop, click. There we go. In a hyperbola, what ends up happening is the sum of, or sorry, it's the set of all the points. Every single point that you pick on the hyperbola is going to be equal to the difference of the distance to the two foci. So an ellipse, we add the distances together. In a hyperbola, we subtract the two distances. Now, what is important is the subtraction has to always be positive. So we actually focus on the absolute value of the difference of the two distances. So when you subtract, if you get a negative number, you disregard the negative. What I mean by that, for example, is if we did like 8 minus 6. Well, 8 minus 6 gives you 2, but if you did 6 minus 8, you'd get negative 2. Ignore the negative, it's 2. They're equal, so it works out. So as long as it is equal to the same number when you subtract them, it does make a hyperbola. And to give you a better visual representation of that, I have my little picture right there, right? So a hyperbola kind of looks like two parabolas, kind of like you have one parabola going one way and another parabola going the other way, or it can go vertically, right? You can have one going up and then the one going down the opposite direction. If you pick any point on there, so for example, if you look in my picture, look at the pink point on the right-hand side. That pink point, I drew one line going all the way to the other side's focus. That distance is D1. And then I drew from that pink point the distance going kind of down to the focus next to it, and we call that distance D2. Well, if I then pick another point, a blue point on the left-hand side, and I know that doesn't look pink and blue, but I swear it is. If you pick that blue point on the left-hand side, you'll see that when I connect to the first focus on the left, it was D3, and when I connect to the second focus on the right, it's D4. What ends up happening then is if I take the absolute value of D1 minus D2, and I take the absolute value of D3 minus D4, they're going to be equal to each other, and that's our constant. And just like with ellipses, you could pick any other point and make it D5 and D6 and do a subtraction problem, you'll get the same number. Pick D7 and D8 and do a subtraction problem, you'll get the same number. It'll happen every single time that distance will give you the same constant value. Okay, this next part, what I drew over on the right-hand side there where you can see that white box, I don't like what I drew. Not that it's bad, it's just missing pieces, and then I redrew it and it got ugly. So let's draw it together. Oop, let me click on the right window. Click, click. Okay, let's go ahead and draw this together so you can see. So on the right-hand side, this is what you're going to draw. And if you want to watch me do it first and then draw it after, that is obviously okay. Okay, so I have my transversal, correct? So there's a few points that we need to know about our transversal. The first one is going to be this one right here. We're going to call this the center. Okay. And when I connect through the center to my two focuses, or my two foci, we're going to have this here. Not that one up top. Disregard that one. There you go. Click. So right here, you're going to have a focus here and a focus over here. And there. Okay, so I have my two focus points, right? That part should be pretty straightforward. That's very similar notations to what we've been using. All that stuff's kind of the same. There is a couple things here, though, that are a little bit... Actually, hold on. One other thing that we have to make note of here. Right here, this right here, and this right here. Those would be your vertexes. Or vertices. I'm going to use the proper plurals. Okay, so there's my vertices. Okay, so the first kind of new term is going to be this right here. See that dotted line right there? That is called the transversal axis. Transversal axis. That's that axis that runs through the two foci, through the two vertices, and through the center. Again, we could turn this completely upside down, or not upside down, sideways, right? We could turn this sideways and it would be the same exact thing. Just the transversal would run up and down. So just be mindful of that. It doesn't always have to run side to side. It just does in this case. A couple other pieces we want to note here. We have some lines on here that you all will recognize, but I need them to do this next part. If I were to draw a line through the center right here, that kind of came up here and just grazed past this side of the transversal and across, sorry, this side of the hyperbola and this side of the hyperbola, and another one that came through this way and through the center and grazed past we know we would call those the, I'm going to pretend you answered me there. Those are the asymptotes. We know that. So you have those two asymptotes there. Well, what that's going to do is it's going to create this box shape right here. Where this asymptote, let me remind myself, right here, this vertex right here, when it comes up here and connects to the asymptote, and comes down here and connects to the asymptote, and obviously my picture is kind of rough, but it's going to come over here and connect, over here and connect, and over here and connect. Really ugly. Looks way better when I drew it with my hand, but there's going to be that box right there, that box that's created here, 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 and here. Note that these points should be on the asymptotes, even though mine are not. They should be on the asymptotes. But that's going to create the next piece that we need. One more color. Last piece that we got to add on here. If I connect the center straight up to this point right here, and straight down to this point down here, we call this the conjugate axis. The conjugate axis. So those are all my names. Those things are super important because that's going to be where we get our A, our B, and our C from, which we're going to use in the formula in just a minute. So let me draw this one more time over here, just to make it make a little bit more sense. Here, just for this part, because it's going to be kind of important. Here, and then we know that we have this axis that goes up this way. Okay, so our pieces here that we need to know are letters. So firstly, this piece right here from the center to the vertice, that's going to be my A. Right? And right here when I go up on the conjugate axis to the point up top, that's going to be my B. And the last one is wherever the focus is, the distance from the center to the focus is going to be C. So A is the center to the vertex, C is the center to the focus, and B is the length of half the conjugate axis from the center up to where the conjugate axis would connect when you were to make a box there with the asymptotes. Kind of weird, but I don't think it's going to be super important that you understand that clearly, because really what we're working on with Pre-Calc is that I need you to be able to take those equations and write the equations and be able to identify the parts of the equations. The actual graphing it doesn't pop up on the exam, so if that part's still a little confusing, don't overwhelm yourself. It's not the most critical part, okay? So we go back into our notes. Let me show you the picture that I did draw. Maybe that makes a little bit more sense, but you can see that there's a couple things missing there. I'm missing the conjugate axis. I'm missing where B is at. So that's kind of why I redrew the picture. But if that picture is a little bit clearer, which it clearly is, that's fine. Just remember that you need to add the conjugate axis and B on there. You may want to look up a picture that's a little bit more clearly drawn. If you just type in hyperbola, you'll see the dotted line box that goes around there. All right, so we have a formula, and again, you don't have to necessarily memorize this formula. It's going to be given to you when you take your test, but there it is in standard form. The hyperbola is going to look very similar to the ellipse. You've got x minus h squared, y minus k squared over a squared and b squared. The difference this time being is instead of being addition in the middle, it's subtraction. With the ellipse, I could just kind of point out that a squared and b squared switch depending on which side's the longest. It's a little bit weirder in this one because it is a subtraction problem. It doesn't matter what goes first. A squared will always go first, and b squared will always go second, right? The transversal axis has to go first. The conjugate axis has to go second, has to be the subtraction part. So that means that the y and the x are going to switch. The x keeps the h every single time, the y keeps the k every single time. It's just that if the ellipse is open on a horizontal axis like the ones I drew up above, then you're going to have the first formula. If the hyperbola, I said ellipse, didn't I? I meant hyperbola. If the hyperbola is opened up so that it's opening up and down instead, you're going to use the second formula. It's opened up on a vertical axis. So it's going to open up along the transverse, your transverse axis is going to run vertically. So 2 formulas, keep those in mind so that we can use those. All right, let's take a look at our examples. We got 2 examples to look at today. So example 1. Example 1 says, find the standard equation of a hyperbola given that the vertices are at 0, 2, and 4, 2, and the foci are at negative 1, 2, and 5, 2. So taking a look at that, the first thing that I did is I drew kind of a quick sketch here just to kind of get me thinking in the right direction. Right? So I said, okay, if I have my coordinate plane, if I graph the first vertice at over 0 up to 1, 2, let me put these points on 1, 2, 3, I think I go over 5, right? Yeah, 5. 1, 2, 3, 4, 5, and negative 1. Okay, let's switch colors so we can see it clearer. Okay, so if I go ahead and start with my vertices I'm going to do in pink, right? So over 0 up 2, there's my first vertice, and then over 1, 2, 3, 4 up 2, there's my second vertice. I hate that it does that. Okay, and let me pull out this blue. Let's put our foci at negative 1, 2. Eventually I'm going to figure out how to not do that. And at 5, 2. So there is my picture. This makes something super important to me right away, right? If it is opened up like that, then it's going to look like the 2 examples that we already looked at. It's going to have that horizontal transverse axis. So I already know the formula I'm going to use in this problem is going to be the x first. X minus h squared over a squared minus y minus k squared over b squared equals 1. So I already know that. Puts me up into a nice, good spot. So the first thing I want to find then is I want to find my h and k, right? We can find that center pretty easily. So if I want to find the center, I have to find the midpoint. And you could find the midpoint, honestly, of the vertices or the foci. The center of the graph is going to be in between the vertices and in between the foci. They're all going to be equidistant. I think in the notes, let's see, I went with the vertices. So let's do it with the vertices. So we're going to do the midpoint formula for our center. So I'm going to take my 0, 2, and my 4, 2. So we're going to take 0 plus 4 divided by 2, my x's, and then take the y's, the 2 and the 2. 2 plus 2 divided by 2, which is going to give me 4 over 2, which is 2, and 4 over 2, which is 2. Ooh, look at that. Look at that. So important notes here then. This is going to be h. This is going to be k. So I already know this part and this part of my formula. If I can just find a and b now, I am in good shape. So I started with a first. A is pretty nice. Once I put this in my graph, all right, if I come over to my graph and go over 2, up 2, and put that point there, well, remember a is the distance here between the center and the vertice. Well, this is pretty easy then. I go over 1, 2, so I know that a is equal to 2. And look at that. Just like that, I have that part done. The next thing that I had to look at then is I had to figure out what b was. B, I know, if I think about on my graph, right, b is going to be some point, and I'm going to go down just to make sure I have space, some point right here, right? Some point that if I go straight down, it's going to connect there. I know my a here is 2. Hold on for a sec. Teaching live is kind of weird like this. I don't have my notes to look at. Why didn't you write that down? Mr. Nock, what did you do that for? So a squared, we're going to use a squared plus b squared equals c squared here. I'm just trying to recall why I want to do that again. Is it the same as the last one? You know, just watch me struggle for a minute. It's fun. Struggling's fun. Struggling's a good time. Okay, so we know c is over 1, 2, 3, right? C is the distance from the center to the focus. So c is equal to 3. And I can tell you what I did in my notes is that I did to find b, I did a squared, that's not equal, a squared plus b squared equals c squared. And I just used these a's, b's, and c's and did the problem. And I want to justify why I did that to you. I don't want you to be like, well, why did he do that? Why did Mr. Nock do that? You know, guys, that was a solid question. I'm going to make a second video so that I don't sit here wasting your time. I'll make a second video explaining that part. So if you're not sure and you want to know why I used a squared plus b squared equals c squared here, you can look at that second video. Now, know that this a squared plus b squared equals c squared is different than the ellipse. Remember, I said in the ellipse it was weird. In the ellipse, it was like b squared plus c squared equals a squared because b and c were the a and the b technically. In this problem, it's not going to work that way. B is this part here. A is this part here. And for whatever reason, this is equal to c. And actually, I know exactly why that's equal to c. It's equal to c based off that distance problem, right? We know that this point right here, this point here, would be on our hyperbola. There we go. Once I started talking about it, it made sense. This is on our hyperbola. So the distance from here to the focus is c, and here to this focus is c plus a. So, sorry, this is not c. This is c minus a, and this is c plus a. So the a and the minus a cancel out, and you get 2c. So the distance is 2c away, so half of that's c. So that's why the c is there. Again, if you're really confused on why that happens, I can show it to you. But just remember that in the ellipse, it's b squared plus c squared equals a squared, because b and c are a and b in the actual Pythagorean theorem. Here, a and b happen to be a and b in the Pythagorean theorem, so it works out really nice here. So plugging this in, then we're going to have 2 squared plus b squared equals c squared. So 2 squared, or 3 squared. So I get 4 plus b squared equals 9. Subtract that, I get b squared equals 5. And just like with the ellipse, I'm going to stop right there because I don't need b. I need b squared for the formula, right? Over here you can see that it uses b squared. So if I just leave it as b squared, I'm good. And I have my answer, right? It's going to be x minus h, which we said h is 2, squared, over a squared. Well, I know a is 2, so a squared is going to be 4, minus y minus k. We said k is 2, so y minus 2 squared, over b squared. Well, we already know b squared is 5, so I'm just going to put a 5 down here, equals 1. And there I have now written the standard equation of my hyperbola. This is it. There you go. As always, I have my nicer version coming up in just a second that you can look at how I did that. Okay, so going on then to our second example. Second example says we want to sketch the hyperbola of 5x squared minus 3y squared plus 8x plus 16. Really important here. I'm going to sketch this hyperbola, but I didn't do it in the notes because I did it and it looked terrible, and so I didn't put that in there. I'm going to do it on here, but for your exam, if we have to take those exams when we get to the end of the year, you don't actually have to sketch anything. Like, it's a multiple choice exam, right? You don't have to sketch anything. Really, what I need you to be able to do is do the completing the square step with this, and then tell me what are the foci, what are the vertices, what is the center, what is A, what is B, what is C. If you can tell me those things, then you're in good shape. Really, like I said, that's what I need. So when we go to do this, remember that we're going to set up our completing the square problem. So we're going to organize all our stuff into the proper order. So I want my x's to come first. So 4x squared, and then plus 8x. When I say proper order, what I mean is we're putting our x's together, We're putting our y's together. And then we're going to put our constant on the other side of the equal sign by itself. So I've got my x's now next to each other. I want to now put the y's next. So I've got minus 3y squared. It looks like there is no like single y term, right? Just the y squared. So I'm going to stop there. Last thing I do is I got to take the 16, move it to the other side. So I'm going to subtract 16, and so I know this equals negative 16. So now I can do my completing the square. What happens though is because there's two x's here, but only one y, I only have to complete the square with the x's. That's it. With the y, we're going to do something a little bit funny to that one. That way we can see what we're doing. So over here, with my x's, the first thing I do is I need to factor the 4 out, because you know that to do completing the square, we have to have a leading term of 1. So when I factor the 4 out, I end up with x squared plus 2x, and I'm going to leave my blank space to do my completing the square step. Over here, I've got my y squared, but the thing about the y squared is there's nothing to complete the square with. I'm just going to take the 3 out and put the y squared in parentheses. And again, it equals negative 16. Since I'm doing a blank over here, I need to make sure I add a blank over here. And since I factored a 4 out, we know that whatever we put in this blank, we have to multiply it by the 4 because we factored the 4 out over here. So now I can do that completing the square step. So for completing the square, we're going to take this middle term and divide it by 2. I get 1. Literally square that and mathematically square that, and I get 1. So I'm going to put a 1 here and a 1 here. I can then go ahead and factor this. So it's going to factor into, go back to my color. When I go to factor that, put my 4 on the outside. We know that x squared plus 2x plus 1, the two things that multiply to make 1 and added to make 2, is this number right here that I put in a box, 1. So I'm going to get x plus 1 times x plus 1, which we can write as x plus 1 squared. Here I've got my minus 3 times the y squared. And lastly, we do our math over here. So 4 times 1 is going to give me 4. And negative 16 plus 4 is negative 12. With me so far? Good. I had total responses there. I'm glad that all of you are totally 100% with me. So next step is we got to turn this into, remember our equation is supposed to be equal to 1, not equal to negative 12. So I need to make this negative 12 go away. And the way we're going to do that is by dividing the negative 12 away from that. So this will now simplify to 1. That's my goal. Well, if I divide this by negative 12, I have to divide everything over here by negative 12. So I'm going to put a negative 12 under here and a negative 12 under here. And I notice that something's going to happen here. It's going to change my signs, right? It's going to cause this to turn into the positive and this to turn to the negative. So my equation is actually going to flip spots. So I'm going to start with the y's first. I'm going to start with this negative 3 over negative 12. So those negatives are going to cancel to make positive. I have my y squared on top. And I know that 3 over 12 simplifies to 1 over 4. So I just need a 4 on the bottom. Over here, this is going to be 4 over negative 12, so that's going to become my new negative. Well, 4 over 12, I'm going to keep my x plus 1 squared on top. 4 over 12 simplifies to 1 over 3. So I end up with minus x plus 1 squared over 3. So there is my equation now. So like I said, the important things we got to pull out of here. Let's look at A and B first. A is always going to be the thing underneath the first number, the first positive thing. So in this case, the 4 represents our A, but remember that's the A squared. So to get A, I have to square root 4, which in this case comes out to a nice number, 2. To get B, I take the thing under the second fraction, which is the negative fraction, and I square root that, and I'm just going to leave that as square root of 3. It's 1 point something, right? Coming over then to the next part, we have to get our C. And C is going to be done by doing a squared plus b squared equals c squared. So a squared is going to give me 4. B squared is going to give me 3. That's going to give me c squared. So I get 7 equals c squared. So square root of 7 is going to be c. So there's my A, B, and C. Like I said, the other important things are going to be our foci and our vertices and our center. So the center is easy to find. Remember, the center comes from right up here, my h and my k. Well, the h in this problem, it looks like a positive 1, but remember when I plugged in, it became opposite. So my h here is going to come from the x, which is going to be negative 1. And my k is going to come from my y. Well, there's nothing being added to y. That means the center for the k is at 0. Remember, if it's just y squared or just x squared, it gives you a 0. So my center is at negative 1, 0. this puts us in really good shape to be able to actually graph this. Like I said, though, this is not the important part. If you can get the center and all that stuff, that's really what I wanted you to be able to do. Okay, so my center is at -1, 0. So there's going to be my point. This equation, though, notice that the y squared is leading. Instead of the x squared being up at the front, the y squared is the positive thing up the front. That tells me this hyperbola has a transverse axis that's going to be vertical, not horizontal like we've done with every single one so far. So I'm going to take that a, and instead of going left and right with it, I'm going to go up and down with it. So a is at 2. Remember, a represents the distance from our center to our vertices of our focus. So if I go up 2 units, 1, 2, that's going to be the sorry, lost track of what I was saying. Yeah, that's going to be my first vertice. And if I go down 2, that's going to be my second vertice. So if I did ask you what the vertices were, you could now tell me the vertices are at -1, 2, and -1, -2. So I just added 2 and subtracted 2 to the y value. The focus is a little bit tougher to get to because it's square root of 7. So I'm going to just go, we know the square root of 7 is approximately 2 point something, right? It's in between 2 and 3. So my focus is going to be, if I put my graph up to 3 and down to -3, I know my focus is somewhere in between there, right? So for foci, I'm going to keep the -1s. That doesn't change. It's just that now I take a positive square root of 7 that I added to 0 and a negative square root of 7 that I added to 0. And that would be my 2 foci points. From there, I can go ahead and make a quick sketch, right? If we were going to put the b on there, right, we could account for that too. Let's talk about what b is going to do in there just to make it make sense of why we have b. So remember, the b is square root of 3. That's going to be your transverse axis. Square root of 3 is a little bit above 1, but definitely below 2, right? So it's going to go to like right here. And if I had one here, hold on, this is 1 and a little bit more, 1 and a little bit more, so it's going to go like right here. Right there. So if I were to turn that into like a square with the vertices, right? You come and see that little square that's created there? If I connect the corners of that square through the center, here and there, this is not good, there. That kind of lines you up for what your hyperbola is supposed to look like. I know that's a lot of colors going on there, but we know that this is our center. Here's our vertex. It's going to come out to this asymptote and this asymptote, and then this one's going to come out to this asymptote and the asymptote that was right here. And that would be our hyperbola, that green thing right there. Like I said, though, if you could tell me what A, B, and C, the center, the vertices, and foci are, that's more what you could expect on your exam. In fact, I think your review just stops right here. Just says, tell me what this is. But obviously, they might give you this until you turn it into that, or give you this until you turn it into that. So just be aware that that's really what you need to do. I don't think the graph is as strictly important, but it's cool to see how it all kind of goes together. I think it makes it a little bit more sense. So, well, that's it. Let me go ahead and put this up before we're done. There are my answers worked out a little bit nicer in nicer colors. Like I said, I didn't draw the picture or finish example 2 the way I should have because I don't know why I didn't. I think I started writing it at school and then I came home and I went to record the video and just it was too far gone. So there you go. Use that to help you. Go ahead and let me know if you have any questions on it. I know hyperbolas are a little bit tough. That was a long video to explain that. So best of luck. Let me know how I can help you. Bye, guys.